The scientific method is employed when creating and executing an experiment. The purpose is to have a systematic way of testing ideas and reporting results in the process of scientific inquiry. A key component of the use of the scientific method is that it ensures that experiments should be able to be replicated by anyone. If that is not possible, then the results are considered invalid. The scientific method is a method for conducting an objective investigation. It is of utmost importance because it is a systematic process of inquiry in which scientific problems arise. Its more important point is that of verifying the truth of the hypothesis that arise from the capabilities of the scientist. We're going to begin step by step with examples. First, we're going to make observations. Basically, we need to ask a question. A lot of people think that the scientific method starts with forming a hypothesis. The reason for this misconception may to be because many observations are made informally. After all, when you are looking for a project idea, you think through all of the things you have experienced, observation you have made, and try to find one that will be suitable for an experiment. Although the informal variation of step 1 works, you will have richer source of ideas if you pick a subject and write down observations until a test able idea comes up. For example, let's say you want to do an experiment but you need an idea. Take what's around you and start writing down observations. Write down everything, include colors, timing, sounds, temperatures, light levels. You get the idea. You may think the hypothesis is the start of the scientific method, but you will have made some observations first, even if they were informal. What you observe leads to ask a question or identify a problem. For example, observation question. I observed that the leaves of the trees are green. Why are the leaves green? The second step is to propose a hypothesis. It's easy to test the null or no difference hypothesis because you can prove it to be wrong. A hypothesis is a statement that can be used to predict the outcome of future observations. The null hypothesis or no difference hypothesis is a good type of hypothesis to test. This type of hypothesis assumes no difference between two states. Here's an example of a null hypothesis. The rate at which grass grows is not dependent on the amount of light it receives. Even if I think that light affects the rate at which my grass grows, probably not as much as rain, but that's a different hypothesis. It is easier to disprove that light has no effect than to get into complicated details about how much light. or wavelength of light. However, these details can become their own hypotheses, stated in no form. For further experiment, it is easy to test separate variables in separate experiments. In other words, don't test the effects of light and water at the same time, until after you have tested each separately. For example, I make two hypotheses. The leaves of the trees are green because they have pigments called chlorophyll. The leaves of the trees are green because they perform photosynthesis. Third, design and analyze data and experiment to test the hypothesis. Record experiment data. Represent the data in the form of a chart or graph, if applicable. You may wish to perform a statistical analysis of the data. When you design an experiment, you are controlling and measuring variables. There are three types of variables: control variables, independent variables, and dependent variables. You can have in control variables. You can have as many control variables as you like. These are parts of the experiment that you try to keep constant throughout an experiment, so that they won't interfere with your test. Writing down control variables is a good idea because it helps make your experiment reproducible, which is important in science. If you have trouble duplicating results from one experiment to another, there may be a controlled variable that you missed. Independent variable. This is the variable you control. Dependent variable. This is the variable you measure. It is called the dependent variable because it depends on the independent variable. For example, to demonstrate why the leaves are green, we grab a leaf and put it in a jar and put it to a boil. After, we can see how the alcohol turns green. We demonstrated the hypothesis. And the last is accept or reject the hypothesis. Do you accept or reject the hypothesis? Communicate your conclusion and explain it. For many experiments, conclusions are formed based on informal analysis of the data. Simply asking, does the data if the hypothesis is one way to accept or reject the hypothesis? However, it is better to apply a statistical analysis to data. To establish a degree of acceptance or rejection, mathematics is also useful in assessing the effects of measurement, errors, and other uncertainties in experiment. For example, in conclusion, hypotheses 1 and 2 are valid. Since the leaves of the tree are green color because they contain a pigment called chlorophyll, indispensable to realize the photosynthesis. Um, if the hypothesis is accepted, accepting an hypothesis does not warrant that is the correct hypothesis. This only means that the results of your experiment support the hypothesis. It is still possible to duplicate the experiment and get different results next time. It is also possible to have hypotheses that explain the observations. Yet is the incorrect explanation. Remember, hypotheses can be disproven, but never proven. If the hypothesis is rejected, we need to back to step 2. If the null hypothesis was rejected, that may be as far as your experiment needs to go. If any other hypothesis was rejected, then it's time to reconsider your explanations for your observations. At least you won't be starting from scratch. You have more observations and data than ever before. As a review of the steps, I will describe a brief example in the use of the scientific method. Step 1. Make observations. We want to study weather. The rate of free fall of the bodies depends on its mass. We dropped from a semi-height a chalk and a sheet of paper. We notice that the chalk arrives before the paper falls to the ground. If we measure the mass of the chalk, we see that it is greater than the mass of the paper. 2. Formulate hypothesis. The body with the highest mass falls most rapidly. Step number 3. Experiment. If we throw the chalk next to a sheet of wrinkled paper, we see that they arrive at the same time. If we follow this line of research and throw a wrinkled paper sheet with another sheet without wrinkled from the same height, we see that the wrinkled sheet arrives earlier. Conclusion. In view of the results, it can be concluded that it is not the mass which determines the one object falls before another on Earth. Rather, it will be the shape of the determining object. We have the example of parachutis. Its mass is the same, with the parachute open and unopened. It falls much fast if the parachute is locked. Remember, we need 4 steps for make a scientific method. 1. Make observations. 2. Formulate hypotheses. 3. Experiment. And last, conclusion. And if the hypothesis is rejected, we need back to step 2.